We're going to continue with the notes of section 4.2. This one is a standard form and graphing. We're going to graph. Remember that last video was vertex form. We had the form y equals ax minus h squared plus k. That's the vertex form. Right now what we are going to cover is a standard form. So by the end of this video, you're going to be able to graph a quadratic function from a standard form. What is the standard form? We have ax squared plus bx plus c. We have three terms. And the vertex form, we have it in this form. Remember that a in both forms is the rate. It's going to tell us how much is growing. It makes the parabola wider or narrower. To graph in vertex form, use transformation to find the vertex. Okay, we find the vertex first. We saw that one in class. Use your rate to get other points. Remember that the rate we were using 1, 3, and 5. And I'm going to continue with those ones. Now, to graph a standard form, we're going to find the axis of symmetry. And we have a formula for those ones. Axis of symmetry. And find the vertex. Use your rate to get the other points. Same rate, 1, 3, and 5. We're going to do a brief review, domain and range, what we saw today. Remember that domain is all your x values. And I have this color here. All your x values is your domain. So the first one, what is the domain? From negative infinity to positive infinity for every single one of these functions. What is the range? Is the y value. Remember the y value. Which number is this one? Negative 3. So we have, I don't have graph at this bottom part, so my graph starts at negative 3 and goes all the way up to positive infinity. So I have negative 3, comma, positive infinity. Let's go to this function. Now my graph opens down. It doesn't open up like this one. Open up. This one opens down. So I have all my graph is in the negative infinity part. So my range is going to be negative infinity, comma, where the graph stops at 1 here. So negative infinity to 1, close bracket. And the domain is from negative infinity to positive infinity. Remember that the domain is all the values. Start from the negative, we go, this graph keeps growing to the left and this growing to the right. So that's the reason why we use positive, from negative infinity to positive infinity. Problem number 3. There is no graph here. So I'm going to say this graph starts from negative 5. This is negative 5, bracket, negative 5, comma, to positive infinity. And the domain is just negative infinity to positive infinity. That's the solution. Second part, finding the axis of symmetry. We're going to call it AOS. We're going to use the formula x equals negative b over 2a. Where are those values coming from? From your standard form y equals ax squared plus bx plus c. We're going to use the values of a and the values of b. Included, if they are negative, put the negative, and so on. But remember, you have a negative in front of the formula, so that negative will cancel if you have a negative in your b or your a. Now, this axis of symmetry is a vertical line that goes through the vertex. So if you have a vertex, for example, I'm going to say a vertex 2, 0. Okay, that means I'm moving 2 units to the right, and I don't have movement in the y-axis. So the axis of symmetry is going to be an imaginary line that goes through that point. Okay, and I'm going to call this one x equals to 2. This is your axis of symmetry. That's where the parabola is going to be split into 2 equal parts. And what we're going to do with this one is, it's the line that every point can be reflected over and still be on the function, represented as x equals whatever number, okay? And in this case is x equals to 2. Find the axis of symmetry of the following quadratic function. So we are going to find those axes of symmetry. So in this case, for example, the first problem, I have x squared plus 16x plus 71. What is the value of a? Remember that we have ax squared plus bx plus c. A is 1. I don't have a number. I'm going to add 1. So a is equals to 1. B is equals to 16. C is not important in this problem at this moment. We just need to find the axis of symmetry. So in this case, my formula is x equals to negative b over 2a. What is this one equals to? Negative b, 16, and then 2 times a, which is 1. So what is x is equals to negative 16 over 2. And this is equals to negative 8. So this is my axis of symmetry. X equals negative 8. So you will go and count 1, 2, 3, negative 1, negative 2, negative 3, negative 4, negative 8. And that's where the parabola is going to be split in half. So negative 8. This will be the first problem. Problem number 5 in this case. Again, same. I don't have a value of a visible, so I'm going to add 1. So a is equals to 1. B is equals to negative 6. B is negative 6. This is a mistake. This is a, b negative 6. So I have x equals to negative b over 2a. So this is equals to negative b is negative 6 over 2 times 1. Let's be careful with those negatives. Negative and negative is positive. So what I have here, x is equals to 6, 2 times 1 is 2, and 6 divided by 2 is 3. So x is equals to 3. This is my axis of symmetry. Axis of symmetry. Problem number 6. We have, look at this, a is equals to negative 3, b is equals to negative 24. I don't care about c at this point. Let's do this one the same. Okay, this function is not completed in standard form. So what I'm going to have here is fx equals to 2x squared. I'm missing the x factor here, plus 0x minus 18. If you are missing an x, put a 0x. And that's what we are going to do. So, my values of a is 2, and b equals to 0. This 0 here. A is 2, b is 0. Let's finish this one, number 6. X equals to negative b over 2a. This is equals to negative 24. Negative 24 over 2 times negative 3. What is this one equals to? Negative and negative is positive, so you have 24 over negative 6. You're going to have a negative axis of symmetry. So x is equals to 24 divided by 6 is negative 4, so negative 4. This is my axis of symmetry. And here you have x equals negative b over 2a. I like to write the formula. This is equals to negative 0 over 2 times a. So 2 times 2. 0 is in the numerator, so everything is going to be 0. It doesn't matter if you have 0 over 4, let's say negative 4. So x is equals to 0 divided by negative 4 is 0. 0. So the axis of symmetry is 0. That means that line goes through the y-axis. This is going to be your axis of symmetry. Finding the vertex. To find the vertex, we need the axis of symmetry. Okay, that reason why these problems 8 and 9 are coming from this problem, because we are going to use the axis of symmetry to find the vertex. Now here, what I have is fx equals to x squared plus 16x plus 71 from example 4. The vertex is a point. Remember, the point h, k, order pair, that has to be on the axis of symmetry. Since we know it has to be on the axis of symmetry, we know the x coordinate. We know the value of x. To find the y coordinate, we plug in the x value to solve for y. So what we do is, from this example, example 4, I know that the x value is -8. So the axis of symmetry, x equals -8. So what I'm going to do is f of -8 is equals to -8 to the second power plus 16 times -8 plus 71. Now we know that 8 to the -8 to the second power. I'm going to continue here. F of -8 is equals to positive 64, because -8 times -8 is positive 64. 16 times -8 is equals to -128. And then I have plus 71. If we add and subtract all these values, we're going to have that f of -8 is equals to 7. Or, this one is the same as having y equals 7. Okay? Y equals 7. So my vertex is, I have the value of x, -8, comma 7. That's my vertex, -8, comma 7. Let's do one more here. I have -x squared plus 4x minus 1. We need to find the axis of symmetry. The axis of symmetry is not given in this function. So I have a is equals -1. See this negative? -1. b is equals to 4. So x is equals to -b over 2a. This is equals to -b is -4 over 2 times -1. Negative and negative is positive. So we have that x is equals to positive 4 over 2. 2 times -1 is -2. But -4 makes it positive. And 4 divided by 2 is 2. So my axis of symmetry is 2. X equals to 2. Now what I do, make the substitution. Y equals -2 to the second power plus 4 times 2 minus 1. 2 to the second power is 4, but I have this negative outside. So I have -4. 4 times 2 is 8 minus 1. So what I do, -4 minus 1 is -5. So 8 minus 5, y is equals to positive 3. So what is my vertex? My vertex is 2, 3. Remember, this point is your axis of symmetry. And that means if I put it here, I'm going to do another one. 2 and 3. So I go 1, 2, 1, 2, 3. This is your vertex, and as you can see, is in your axis of symmetry. Okay, let's turn this page around. What we're going to do, find the minimum and maximum and range using the previous example, so we don't waste our time. Remember this problem. We're going to write the vertex. The vertex was -8 and 7. So your maximum or minimum value is always going to be the y value of this vertex. So you're going to have, see this one opens up. This parabola is going to open up. This vertex is -8, 7. So you're going to have a minimum value, minimum of y equals to 7. Okay, this is your minimum value of y equals to 7. This one. What is the vertex? The vertex of this function was 2, 3. I can see that the value of a is negative, so that means that parabola is going to open down, so you're going to have a maximum value. Maximum value. So your maximum value is y equals to 3. So as simple as that one, y equals to 3. What we're going to do now, we're going to graph. We're going to graph graphing quadratic functions from standard form. As you are going to see, vertex form is easier to graph. Graphing quadratic function in standard form, we're going to have some steps. Step number 1, find the axis of symmetry, then the vertex. Step number 2, find the vertex. Step number 3, does that graph opens up or opens down? And then we're going to use the rate. Okay, so my first example is 2x squared plus 4x minus 1. So remember, I'm going to use, this is A, this is B. So axis of symmetry is x equals negative b over 2a, where a is equals to 2. B is equals to 4. So this is equals to negative 4 over 2 times 2. Okay? So negative 4 over 4. So x is equals to negative 1. That's the first value. That's the first value. Now I need to find the value of y. This is my axis of symmetry. Now let's find the value of y. So I have y equals 2 times negative 1 squared plus 4 times 2, or negative 1, negative 1, negative 1, minus 1 here. So y is equals to, negative 1 to the second power is positive 1 times 2 is 2. Then 4 times negative 1 is negative 4 minus 1. So what I have, negative 4 minus 1 is negative 5, and negative 5 plus 2, so y is equals to negative 3. So I know my vertex now. My vertex is negative 1, comma, negative 3. Now, what is the step number 3? Does that graph opens up or opens down? The value of a is positive. So that means this parabola is going to open up. Okay? And a is equals to 2. Why I need a equals to 2? Because I'm going to use the rate 1, 3, 5. And my a is 2, it's not 1. So final step is rate. The rate, remember that we use 1, 3, and 5, but because my value of a is 2, we multiply times 2 equals to 2. Times 2 equals to 6, times 2 equals to 10. I don't think we're going to use this value here. So let's graph. Now we're going to graph. We are going to need my vertex, negative 1 in x, negative 3 in y. So what that means, this is my axis of symmetry, this line. Let me draw this one. This is my axis of symmetry. That's half, where the parabola is going to split in half. Then I'm going to use my rate. I know it opens up, so I'm going up. I'm going 2 units up. From this point, I'm going to go 1, 2, 1 to the right. 1, 2, 1 to the left. From this point, I'm going 6. 1, 2, 3, 4, 5, 6. 1, 2 to the right. 1, 2 to the left. And now we're just going to graph. Okay, I'm horrible graphing, so I'm going to give it a try. Here goes my parabola. Left side. And that's your parabola that opens up. It got a minimum value. Let me write the minimum value. It has a minimum value of y equals negative 3. Y equals negative 3. What is the y-intercept? I'm going to write here. Y-intercept. In a standard form is the value of c. So this one is negative 1. So 0 in x, negative 1 in y. That's the y-intercept. Okay. Problem number 13. Same steps, different numbers. So I have a is equals to negative 1. B is equals to 4. Okay. So the formula is x equals negative b over 2a. We're finding the axis of symmetry. So this is equals to negative 4 over 2 times negative 1. So this is equals to negative 4 over 2 times negative 1 is negative 2. So x is equals to negative 4 divided by negative 2 is positive 2. So we box. Now we substitute that value or plug in. So I'm going to remove this fx and I'm just going to write y equals negative 2 to the second power plus 4 times 2 minus 3. And 2 to the second power is 4, but you have a negative, so negative 4. 4 times 2 is 8 minus 3. Look at this one. Negative 4 minus 3 is negative 7, and 8 minus 7 is 1. Okay, 1. So y equals to 1. So what is my vertex? My vertex is 2, 1. Let me graph this one. My axis of symmetry is 2. Remember, this is axis of symmetry is 2. So I'm going to draw this dotted line in 2. And my vertex is 2 and 1. 2 in x, 1 in y. Now, let's look. Does this, step number 3, does this function or graph opens up or down? The value of a is negative. So opens down, goes down, opens down with a value of a equals negative 1. So instead of going up, we're going down. So the rate is 1, 3, and 5, but negative. So we are going down here. So I'm going down 1, right 1, down 1, left 1. Now let's go 3. 1, 2, 3, 1, 2 units right, 1, 2 units left. And you have negative 5, but we're not going to have space. 1, 2, 3, 4. I can do 1 here. Then we go 1, 2, 3. 1, 2, 3 here. And you graph your parabola. Goes this way and goes this way. And in this case, this is your axis of symmetry. X equals 2. The vertex is 2, 1. And that's your parabola that is graphed. What they ask in the final problem, converting from a standard form to vertex form. So this is my standard form, and we're going to convert this one to vertex form. Step number 1, we are going to find the axis of symmetry. So remember, this is A, this is B. A equals negative 1, B equals 4. So I have x equals negative b over 2a equals to negative b is 4 over 2 times negative 1 equals to 4 negative over negative 2. So x is equals to positive 2 because negative 4 divided by negative 2 is positive 2. Now let's find the value of y. So I have y, I'm going to do it here with different color. Y equals negative 2 squared, okay, plus 4 times 2 minus 5. 2 to the second power is 4, but you have a negative outside the parentheses, so it's negative 4. 4 times 2 is 8 minus 5. Look at this. Negative 5, negative 4 is negative 9, so 8 minus 9 is equals to negative 1. So I have the value of y is negative 1. Now, I know that the vertex is 2, negative 1, okay? The rate is 1. This value of a is 1, but negative, okay? A is equals to negative 1. Now, what else do we have? It's reflected in the x-axis. That reason why it's negative. I'm going to write here, reflects x-axis, because it's negative. So, in this case, my vertex form, remember the vertex form? Y equals ax minus h plus k. So this is the same. Y equals, a is negative 1, parenthesis. I'm not going to write negative 1, parenthesis, x minus h, 2. See how this 2 is positive, so when it goes back to the formula, it goes negative. We always use the opposite. To the second power, I forgot the second power, minus 1. And this is my vertex form of the parabola. If you have any question, you can leave any comment, or you can go to Google Classroom and make any comment. So I hope you have a wonderful day.